So anybody who misses them while they're happening can watch them later, or you guys can watch them later also. Okay, so it's recording. That's working. So while we're waiting on people to join in or come into class, just in case we're missing some, I want to talk about visual logistics here. So I haven't taught in this classroom yet today, so I don't know how chalkboard is going to work with the extended class. You know, is it going to be visible? Obviously, it's going to be visible to you guys in person. Okay. So that's what I'm worried about. I'm worried about the constant movement. Is it moving?
It's like zooming out.
Okay, you know what I'm gonna do? I think.
Oh, yeah.
Oh, this is trippy. Okay, I think I can hold it steady in one spot. That's, oh, no, wrong one. All right, we're gonna try to not auto track. I'm just gonna try to hold it steady here. Okay, I'm gonna leave the camera here. All right, so I'm gonna write some things, and you guys in the extended class, if you want to, again, like give me a thumbs up if you can read it well. So math stuff.
It's backwards.
Oh, it's backwards. I can probably fix that. All right, guys, let me see how I can make it not backwards. Where's my video? Okay, not backwards anymore? Can you read that? It says math stuff. Okay.
Yeah.
All right, we'll try this. Today's not going to be super in-depth, so we'll try it this way. And if it doesn't work out, if for some reason it's grainy or blurry, I can always try to figure out, like on the computer whiteboard, there's some kind of app I can use. But we'll try this. Look at math stuff. I'm going to erase that. Right. So let's make sure it doesn't look weird. I feel like it's still backwards, but it's not here. I don't know what to write. I'm not ready. More math stuff. So here's my name. MAB. All right, it looks pretty clear on my screen. Does it look, well, you guys don't have to look there. It's a little distorted. That's weird. Well, maybe it's better over here. You guys, does that look okay? It looks pretty clear on my computer screen. So we'll try it. It's fine, not terrible. Thank you. Okay, so let's start with more logistics. Today is going to be like half logistics. So we'll be doing this. You guys, my in-person class, we'll come in, we'll get this set up. Hopefully it'll take less and less time every class. So we'll get it set up. We'll have the extended section entering. I will, like I said, I always record these. So extended class, if you can't make it at a specific time to our Zoom meeting, that's okay. These will all be recorded. I'm gonna post them. Usually I post my meetings to I have like a little YouTube channel, and I'll give you more info on that, but I also post them to D2L, like I embed that link in D2L also. So they'll be posted. Now, in-person students, that goes for you too. So this semester, say you have to stay home for a while, like maybe somebody in one of your other classes has the virus or whatever, Sorry guys, I don't. It's the chop. Even with the mask, it doesn't matter. Every time I'm in this room. You know, and you have to self-quarantine or isolate or whatever it is. It doesn't matter why you can't make it to class. I mean, you can always chime into the Zoom meeting like the extended students do. And you can always watch the recordings later. Okay. With that being said, remember that this week, my in-person students, we will be here Monday, Wednesday, and Friday in class. Next week will be different. Next week, our only in-person day, starting next week and on, is going to be Fridays. Monday and Wednesdays, we will all be extended section because I will be at home watching my kiddos. So with that being said, when I'm at home, I have a certain setup. I got like a board, I got like a tripod situation, and I have it set up.
Sorry, is it the electrical science?
This is math analysis for business. So it's really nice. I mean, it's pretty clear, like where you can see me writing and everything. My concern is that I want to make sure that on those days, my in-person students, I don't have any people who need to be here, like, or need to be in a spot where they can see my in-person stuff on campus, like in this classroom. Does that make sense? Yes.
So you said next week that we won't be meeting in person?
Only on Fridays. Starting next week, we'll be in person just on Fridays. And that'll be a day where, like on Mondays and Wednesdays, I'll still be doing the lecture. I'll just be from my own home. So yes, there is an option where you guys could still come in here even though I'm not here and then watch it here. But obviously, I don't think that's probably the best option, like for clarity. Like I said, if you need a place to watch this, like maybe you don't have a device that is gonna work for the Zoom meetings or something like that, let's talk about that so we can get it worked out. But otherwise, I would just say Mondays and Wednesdays, you just watch from wherever you wanna watch. You know, log in on your own device. It's kind of going to be nicer because you have your device here, you have the screen, you can see it clearly, you can be as close as you want to it. I feel like this is going to be trouble when I'm streaming from home at least. So just like I said, with that being said, if you have a problem with that, if you need to come into class, let's talk about it. But if not, just act like the extended session on Mondays and Wednesdays. Okay, so with that out of the way, syllabus, did everybody get it through email? Okay, so I sent so many things, guys. You know, the syllabus, it's pretty straightforward. You know, we've got some exams, quizzes, homework. The one thing that's different about this semester than my usual semesters is that they will all be in my math lab. So that's like the major point in the syllabus I want to talk about is getting on my math lab. I sent a new attachment or something. I sent you the class code for my particular course. So you sign in to mymathlab.com. That's the first thing you put in is that course number. You see that it says this is our class, and then you continue with registration. That is something you purchase. You guys, it is cheaper just to go through the registration and purchase this right there through my math lab. They do have codes in the bookstore if you do need to purchase it through the bookstore. You would just say what class you're in and they'd give you the right one. But you guys, once you get on my math lab, you're gonna see, so far all you'll see is a couple of homework assignments. It's pretty, I don't know if you've used Math Lab before. It's pretty easy to navigate. Like there's a menu, you can click on homework. I think it says assignments. I can't remember, but I think it might say assignments, and then it'll show you what you have going on. Like I said, right now, it has maybe 1 or 2 assignments in there. Nothing is due for us until not the end of this week, but the end of next week. Because this is all just a lot of learning process, guys, for everybody. So I don't want any due dates this week because I feel like we're gonna still be working things out.
Thank you for that.
And you'll notice that we actually start with section 11.1. So our book, if we actually had the book in class, the first 10 chapters would be more like business algebra. And then it goes into the business calculus stuff in chapter 11. So we do start in chapter 11, so don't let that throw you. That is where you should be. Let's see, my math lab, extended class, talked about Mondays and Wednesdays. All right, if anybody has trouble with the math lab, just, we can email about that. In my syllabus, I gave you my office hours, basically every day from 1 to 2. But really anytime, you guys, my office hours are virtual. So basically, if you email me with a question, like maybe you're working a problem and you need help, what I'm probably gonna say is, hey, can you jump on our Zoom meeting? It'll be the same meeting room as normal class that I sent out before, that number and that password. And then we can just jump on and have a private Zoom meeting. Really anytime. I'm pretty available, especially when my office is just a computer I carry around with me. So I want to be very accessible to you this semester because it's this semester. So let's see, I talked about office hours. I think we're ready to do some math. Not a lot of math. Today it's the first day. I don't like to be heavy on it, but I want to give you guys kind of a feel for what we're going to be doing in here. And also, oh yeah, I don't know what's trying to. Oh no, why is it blurred? Do you see it blurred? Guys, I can see this blurry and oh no, it's back. Any camera has some kind of auto zoom that I need to take care of. Okay, we'll see. Sorry. We'll see if it gets blurry again. Still clear? As clear as it gets on there. I think this screen is the problem with the distortion. Okay, so I don't know how long it's been since you guys have had math. A lot of times with this class, it's really all over the place. Maybe you just came from college algebra or a trig class. Maybe it's been a long time. Maybe you've, waited till kind of the end to take this class. I know that happens a lot. But it doesn't really matter, you guys, because I'm going to start as slow as I can. I can't, just review all the algebra that you're going to need, but I can show you the last little bits at least, or the things you need for this class, and then start moving forward. So what I want to talk about first is I want to review your knowledge of functions. Oops, sorry. So functions, definitely an algebra subject, but we use them all the time. We jump in using functions, so I want to make sure we're all on the same page as how to use them, what the notation looks like. So I'm going to give us an easy one. When you see an equation like this, guys, how do I know it's a function? Because it's in function notation. This is what tells me that. It's the f of x, right? This doesn't have to be an f, but most of the time it is. We give our functions a name, and in this case, our function's name is f. You can see g of x or h of x a lot. Sometimes we call functions g or h. They could be anything, honestly. And in applications, usually it's a letter that makes sense for the problem you're working. But we're going to use f for the most part, just in practice. So f of x, what does it mean? It means we have a function f and an input x. X is going to be our input. Of course, y would be our output, but we don't see a y here. Our answer actually ends up being here. So f of x is another way of saying y, what the function equals when x is inputted. So f of x equals 3x plus 5, just a simple linear function. You guys, if I graphed it, it would be a line. What if I asked you to find f of 3? What am I asking for here?
So you're plugging in the value of 3 in for x.
Right, so what I want to do is I want to use 3 as my input. So I say, okay, what is this function value when x equals 3?
14.
Yeah, because I do 3 times 3 plus 5. And I get f of 3 equals 14. So this line here is an ordered pair, right? You can see your x value of 3 and your y value of 14. This ordered pair 3, 14 could go on our graph, you guys. It would be a point on the line that's graphed by this function. Okay, so understanding a little bit of remembering about how the function works, and then let's use them in a new way. So this problem, before I erase it, this is the goal of algebra, right? I want to know, what does the function equal at a certain point? That's basically algebra's goal. And it's a good goal. You guys, I have a function. I want to know what happens when I put in 3. Well, I get out 14. Awesome. But you guys, it's not our goal in this class. Our goal is not about static values. I don't really care a lot of times what the function equals at a certain point. What I care about is how the function is behaving near a certain point. The behavior, the change, how a function's changing is a lot more important to us in this class than just knowing different values of y. You guys, I want to know how the y's are changing. Why are they changing? Are they going up or down, or how fast, you know? So it's really about the change. So I'm going to make a graph for us. And this first section is a lot of graph. You guys, we don't do a lot of graph normally. So this concept is just best explained with graphs. So don't worry, don't think we're just going to keep graphing. We're really not. Okay, but I do have a graph here. And I'm going to create a function. So I'm not going to give it a specific equation because I'm just going to draw whatever comes out. So let's say I've got a function. And maybe it starts down here and it just decreases forever that way. And it comes up to here and it has a hole. And it jumps down to here. And I'll give you some coordinates for these points in a little bit. And then maybe it goes like this. Oh, and there's another hole. And then it goes on forever up like that. So some functions have holes, right? Sometimes there's x values, when you put them in, nothing comes out. You know, it's undefined. We're going to deal with that. But you guys, first, I'm going to give you some x values. So let's say all of this here happens at x equals -3. Let's say that this hole occurs when x equals, let's call this 7. Y values. You guys, these 2 points, I need to know what they are. I need to know, let's say this is y equals 4 and y equals 1. You can pretend this is to scale. It's never to scale. I'm sorry. And then let's say this y value of this hole up here is 6. It's higher than the 7. Oh well. Okay, so let's just pretend this is a really good graph and this all makes sense. Okay, so I'm going to also label another point. It doesn't look like an important point, and it's really not. I'm just going to find one more point that I want to talk about. Let's say this is 5 and this y is 1. So that just looks like a normal one. I have 3 x values on my graph that I want to talk about. Yes, the y values are going to be something I also talk about, but I really want to talk about what occurs at each of these values. So first question, let's actually start with this one that exists. I want to know, as my x values, as my inputs, as x approaches 5, I want to know, what does y approach? Now, before we answer, I need to talk about the word approach because we have a specific definition for this class. When I say approach, if I'm approaching the door, I'm kind of going toward the door, right? I'm on my way there. Okay, so yes, that is our approach, but we have to be more restrictive. If I just say approach in this term, I didn't say which direction I was approaching from. So I have to assume I'm coming from all directions. So when I say as x approaches 5, I mean as x gets close to 5 on this side, and as x gets close to 5 on this side. So we're approaching from 2 directions, but also approach has to be able to be infinitely close to a value on both sides. So we already got the both sides. That makes sense. What do I mean by infinitely close? I'm getting infinitely close to 5 on either side. Let's start with this side. I'm approaching, I hit 4. And then I get a little closer, I hit 4.5. And I get a little closer, now I'm at 4.9. Is that as close as I can get?
No.
Can I add a 9? Can I be at 4.99? Can I add 9s forever and never hit 5? Yeah, I get infinitely close to 5 from this way. Can I do the same thing from the other way? Yes, and you guys, for the most part, we can do this. There are times when we'll find I can't actually get infinitely close to a value from both sides, but we'll talk about that. But this one looks fine. You guys, so as x gets infinitely close to 5 on both sides, what is y getting infinitely close to on both sides? So remember, this is your x, your left, right. Y is the corresponding values that are happening on the graph, right? So I'm getting infinitely close to this value here as x approaches 5. Would you agree that that value is 1?
Yeah.
Now, does the function equal 1 there? Absolutely. But again, I'm not really concerned about that. I don't even care. What I care about is that my graph is getting infinitely close to 1 on either side. So I would say, as x approaches 5, y is approaching 1. And that makes sense because it does equal 1. You get close to 5, you get close to 1. It all is defined and it makes perfect sense. So you guys, let's look at another point. Let's look at this one. So I've got a hole in this graph, which happens. Graphs can have holes. It just means that at this point where x equals 7, my output is actually undefined. Something's going on in the equation there that made this undefined. Fine. What about the approach question? As x approaches 7, what is our y value approaching? So as I get infinitely close to 7 on both sides of x, my corresponding graph up here, the y values, I'm getting infinitely close to this hole. But on the other side, I'm also getting infinitely close to this hole. Does it make sense that, one thing I want to make sure you know is that hole, even though it looks pretty large, it's 1 point. That hole only exists at x equals 7, y equals 6. At 6.01, there's graph there. At 5.99999, whatever, there's graph there. It's only that instantaneous point at 6. So could I say that this graph is getting infinitely close to 6 from both sides? Absolutely. It's approaching 6. Does it equal 6 there?
No.
It doesn't equal anything there. Do I care?
No.
Absolutely not. The answer is 6, even though it doesn't exist there, because I'm talking about the approach. Now, last question. Let's talk about that point over there. So let me leave this, guys, and then I'm going to change these numbers. I know I'm recording this, but I want you to have time to write this stuff down. Sometimes I erase too fast, and if I start doing that, just let me know. Okay, so let's talk about as x approaches -3. So let's go over to -3. Now, I know what the x is approaching. You guys, x always approaches anything. You guys, unless you have a place where x isn't part of your graph, your x's are always going to be nice and smooth. They're always going to count up or count down. X doesn't jump around. So you guys, x is getting infinitely close to -3. Okay. What is y getting infinitely close to from both sides?
1 and 4.
Yeah, it's a problem, right? It's kind of ambiguous. You guys, as we come from the left, y is getting infinitely close to 4. As close as you can get to 4, and then keep getting closer. But from the other side, y is getting infinitely close to 1. So could I say, remember my definition of approach? Infinitely close from both sides. Could I say that y is approaching anything from both sides? It's not. You guys, y is approaching something from the left side, and y is approaching something different from the right side. But unless they're approaching the same thing from both sides, I can't say y is approaching anything. Because remember, which direction are we coming from? We have to assume both if it's not specified. So I'm assuming y is approaching from both sides. So I say, now you can say undefined, or usually I just say does not exist. I do the D and E. It's approaching something, it's not approaching anything. So you guys, limits is what these are called. I'm approaching a limit, and I'll explain that more later, but they are defined in most cases. Even when this value didn't exist on my function, I still had an answer for that approach, right? It still worked. The only time I didn't have an answer for that was when there was a jump. It was a break, when both sides are not doing the same thing. So let's write these same questions. So I wrote them in words. We said we used approaches a lot and all that stuff. But I'm going to talk about the notation that we're going to use, because every time you're not going to be writing this out. So let's start with the first question that we talked about. We were here. Here's how I'm going to ask it. Okay. This is your notation. I've got LIM as an abbreviation for what we call the limit. The limit is the value we're approaching. So if I say, what's the limit? What am I asking for? I'm asking for what is y approaching at a certain point. So what is the limit of this function, whatever this function's name is going right here, as x approaches 5?
The positive one.
Right, it was +1
Yeah.
because x was approaching 5 from both sides, y was approaching 1. So that's an alternate way to answer that first question, or ask and answer it. And you guys, this is the way, the notation we're going to use. So let's ask the second question. What's the limit of this function f of x as x approaches 7?
6.
Yes, it was 6. So that was the whole, but it still was approaching that on both sides. So I still had an answer. And then the third question that I have here. What's the limit as x approaches -3 of this function? Yeah, it's D and E. It doesn't exist. You could do U and D for undefined. I don't care how you write it. I always do the D and E. It doesn't exist. So I'm going to draw a new graph. I'm going to ask questions just by writing them this way. We don't really have to talk it out. And we're going to get the answers. And then we'll be done for the day. Now, there will be a time. I say it like it's like years away. There will be a time in our next class when I can answer that two-sided thing better. But for right now, I don't have the way, so it doesn't exist. Okay, so let's make another graph. Everything's reduced to. Yeah, that'll do it. All right, let's label some points. This is x equals -3. This whole is -2 on the y. This point, or this whole line here, let's say it's +1. Let me not make that look like a plus sign. There. Let's say this x value is 4. We already have this 1, and then we have this 6 again. All right, so what is the limit of this function? We're calling it f of x because that's what we're always calling it. I want to know the limit of f of x as x approaches, oh, I gotta give you one that exists, huh? Let's say over here we've got 7, and we know this is 6. As x approaches 7. So as x approaches this value at 7 from both sides, what's happening up here? What is my y approaching from both sides? Now when I say approaching, it's not a problem if it's already there. It's staying there. That's okay. That can also be an approach. So even on a constant part of a function, you can still have a limit, right? But you guys, it's 6 here, and it's 6 here. It's 6 everywhere. Can I say that this is approaching 6? Yes, you still can. You guys, even a constant function, I know it sounds kind of weird. You say, well, it's not really moving at all. Can I say it's approaching one thing or another? You can. You absolutely can. You guys, we say that the limit here is 6. Now, what about the limit of this function as x approaches 4? What do we got? So here's 4. I'm approaching 1 from that side. What am I approaching from this side? So what's the problem? Yeah, it doesn't exist. And those are the big ones. Like I said, I want to make sure you know that where it doesn't exist. Because where it does, it's usually pretty easy to find. You guys, on this one, does it not concern you that these both don't exist? That doesn't change it, right? It's approaching an undefined value, and that one is too. So are they approaching the same thing? Still not, right? Because this one is approaching 6. It never hits 6, but it is approaching 6. And this is approaching 1.
Yeah, they have the same outcome, but they're still different numbers.
Right, even though it's the same outcome, they came from a different way to get there. That one gets people sometimes. And then what about it? -3?
1.
One side is 1. One side it is approaching 1. It's getting infinitely close. But what's happening on the other side? Is it also approaching 1?
No.
It's not. It's down here at -3. So again, it doesn't exist. And those are sad. These are sad, guys. It's a sad function when we can't find a limit. And that's why we like functions to be smooth, what we call smooth, continuous functions. That is what we're going to work with for the most part, where limits exist. Oftentimes, they're the same value as what the function equals there. That's even better. But we have to be able to deal with these cases that are weird. Let's see. Yes?
How can you tell based on the graph, like whether the function does not exist? How can you tell that though?
So the only time a limit doesn't exist is when you aren't approaching the same thing from both sides. So if they do this and they don't meet, that limit's not going to exist.
Okay.
Every time they meet,
Mhm.
even if they meet around a hole, they're still meeting, they're still approaching the same thing,
Mhm.
and it does exist.
Okay.
And you guys, next time, like I said, 2 days from now, we will make these work, just not today. We have to restrict them in a certain way to get answers out, because our goal is answers, right? But today, they don't have answers. Today, they don't exist. But yeah, that is where I'm gonna stop. Hey, extended people, how was this board work? Cool? Okay, good. You guys, I am trying to avoid as much as possible having to use technology to like write with a smart pen and crap like that, because it's really hard. So if this works, then we're gonna just try to stick with this for now. That's all I got for you. If you have questions for me, you can always email me. And I'll see you next time, if not before.